All right, let's take a look at our homework here. We will be having a quiz tomorrow. I kind of was going back and forth on it, and it will be best to do tomorrow. But probably after lunch. So we'll have some time. There's not a lot new or not much new at all to talk about, really. So we'll have a chance to do some stuff today. We'll have a chance to do some more review problems tomorrow. And then we may start and do a little part of it maybe before lunch and kind of see how that goes. But it should be short enough we can do it after. Okay? All right, so yesterday the discussion with Mrs. Payne was about what? Geometric. Very good. Okay, so you learned something. Geometric sequences of sequence, right? So let's just review here first quickly what we've had the last couple days. And then we'll do a little warm-up problem, and then we'll go over some more questions, and then go from there. So we started with 2 days ago arithmetic sequences and partial sums. So arithmetic sequence is when you have a common difference from one term to the next, which basically means you're adding the same thing on to go from term to term. Now you could be adding a negative, so it would be like subtracting, but that's what's going on. So you add 2, add 2, add 2, add 2, add 3, add 3, add 3, add negative 1, add negative 1, add negative 1. So you're adding the same thing. That's called an arithmetic sequence. So these formulas I will put on the quiz for you. I promise. So you won't need an extra sheet or anything. They will just be on the quiz. Now, they won't. I will just have, okay, arithmetic, and these two will be under there. I'm not going to have this description of what it is. You need to be able to figure that out, right? A sub n is the nth term. S sub n, S stands for sum. That's the sum of the sequence, okay? And so this is the sum of n terms in a sequence, and that is the formula to find the nth term. Actually, the formula to do a lot of stuff. You can find what term a certain term is, what number of the term it is. You can use that to find the common difference. You can use that formula to find the first term of a sequence if you know some of the other stuff. So you can use this formula a lot. And I was making a big deal about that on Tuesday when I was saying, use the formula, use the formula. Plug those things in, okay? And then, so yesterday you had this, okay? So a geometric sequence is a sequence in which the consecutive terms have a common ratio. So on the other one, it was the common difference, right, between the terms. And that was adding, adding, adding. And we talked a lot about how repeatedly adding is like multiplying. Now, if you were to graph these terms, it would make a line in the arithmetic. So the arithmetic, we talked about how this is a lot like y equals m times x minus the x point plus the y point. We talked a lot about how that was really a linear equation, and the common difference is like the what? The slope on a linear situation. Okay, well, in a geometric sequence, it's like an exponential function, and we talked about that. Repeatedly multiplying is like exponentiation, right? Doing an exponential. Like we just got in studying with logs, right? Exponential functions. So the way you can find the ratio is by dividing, what I call dividing backwards. Just like we said to do the arithmetic, you can subtract backwards. So if you've got this kind of a sequence, you can take A2 minus A1, and that gives you the common difference. Or you take A3 minus A2, or you take A4 minus A3. And of course, for it to be an arithmetic sequence, it's got to be the same every time you do that, right? Like sometimes you get those questions, is this arithmetic? Well, the way you test is you take this term minus this term, see what you get. This term minus this term, see what you get. This term minus this term, see what you get. You better get the same thing every time. Okay, well, same thing's true here. You can divide backwards, right? So take this term divided by this term, see what you get. This term divided by this term, see what you get. This term divided by this term, see what you get. Now, sometimes it's obvious, right? You're multiplying by 2. You're multiplying by 1/2. But sometimes it's not very obvious. Sometimes it could be you're multiplying by 2 root 2 or root 3 over 3. I mean, I don't know if we run into very many of those in the homework, but we could, right? So that's where the calculator can come in handy, okay? And there will be some problems where you can't give a decimal answer. I'm going to want, an exact answer, so you have to work with radicals possibly. So we'll be getting into those here a little bit. But you just divide backwards. A2 divided by A1, A3 divided by A2, A4 divided by A3, whatever. Divide backwards. That's called the common ratio R. Okay, so here's some formulas you had yesterday. Okay, so the nth term of a geometric sequence, starting with the first term, and then you multiply by R. And then to get the next term, you multiply by R again. Then you multiply by R again. So those of you that were not here, it would look like this. Okay, here's A1, here's your first term. Then you multiply it by R, right? So let's say you're multiplying by 2 every time, right? So you take your first term, you multiply by 2. And then you multiply by 2 again. And then you multiply by 2 again, right? Well, this is your first term. And then this would give you your second term. And then after multiply by R again, it'd be your third term. And you multiply by R again, you get your fourth term. Well, what do you notice? To get the fourth term, you multiply by R 3 times. So that's going to be A1 times R to the third. So to get your fourth term, you multiply by R 3 times. Always 1 less. And that's why it's n minus 1. That's why it's R to the n minus 1. Okay? So that's just a formula to look at. But isn't that the same as this? Isn't that why the n minus 1 is here? Think what you do. You take, but the difference here is we're adding. So look at the connection in those two formulas. So in this one, it was you start with A1 and you add on D, and then you add on D, and then you add on D, and then you add on D. So to get to the fourth term, you're going to add D how many times? 3, right? You're going to be the first term, and to get to the fourth term, you're going to add on D 3 times. So you're going to have D times n minus 1 added on to the first term. Well, here, you're going to multiply by R 3 times, so you're going to have R to the third multiplied, or you're going to have R n minus 1 times multiplied times A1. So it's just a very, very similar rationale reasoning for how you get that formula. Okay? Now, the sum of a finite geometric series is a little different. So remember, the word series means we're adding. So if we have a finite number of terms, we can add it up, and then you just follow this formula. Okay, so we don't have to worry about where it comes from, but you need the first term, you need the common ratio, and you need to know how many terms you're wanting to add up. Okay, and so, and sometimes it's real easy if you know that stuff, and if you don't know that stuff, like if you have something like this, I equals 0 to 4, 3i. No, not 3i, 3 raised to the I. So let's say you had something like that, you wanted to sum that up, right? Well, what's the first thing, what have I said all week? What's the first thing you should do when you see a sigma? Expand it out. So you put in a 0, you get 1, plus, we're adding here. Then you put in a 1, you get 3. Then you put in a 2, you get 9. Then you put in a 3, you get 27, then you put in a 4, you get, now you're wanting to add those up. Now obviously we just take our calculator and add those up, but what if this said 40 instead of 4? So you write that out. Well, what do you need to know? You need to know your first term, well that's 1. You need to know R, what's R in this case? 3, and you need to know N, and what's N? N is how many terms you have, right? N is how many terms you have, so you have 5 terms. So if maybe this was I equals -6 to 4. You need to figure out how many terms there are. So expanding it out is a good way to do that. And we also talked about how you can subtract and add 1, right? We said you can take 4 minus 0 and add 1. And that tells you how many terms there are when you have a sigma, right? So sometimes you have to figure out how many terms there are. Or maybe you have to figure out what the first term is, before you can apply that formula. But that's the formula that will give you the sum. Okay? And then the last thing, did you have any homework on the sum problems? I actually don't think there were any. Were there in the homework? So I'm gonna give you a chance here in a little bit after we do a little warm up and stuff. You might do this. I'm gonna give you some work time on some problems just on the sum ones. Okay? And that may come here before lunch. And then after lunch we got a worksheet that'll review both the arithmetic and the geometric. Okay? Yeah, but she went through that, right? She went through this for some formulas. Okay, so you've got those, but like you said, I don't think there was much homework on it. Okay, now this is what we had actually started talking about the other day, where I said if you have 1/2 plus 1/4 plus 1/8 plus 1/16, and you did that forever, what would that add up to? That adds up to 1. 1/2 plus 1/4 is 3/4 plus 1/8, that'd be 7/8 plus 1/16 would be 15/16. You keep adding up. The partial sums are getting closer and closer and closer to 1. So you're adding these teeny, teeny bits. Well, the key here is what's R in this? What are you multiplying by each time? 1/2. Now remember, if you don't see that 1/2, all you have to do is on your calculator, take 1/16 divided by 1/8. Remember we just had to say how you divide backwards to get R? So if you think this is a geometric sequence, 1/16 divided by 1/8 is 1/2. 1/8 divided by 1/4, 1/2. 1/4 divided by 1/2, 1/2, and it'll give it to you, okay? All right, now, so if R is less than 1, and we say absolute value, so it could be negative 1/2, right? So like if this was alternating, right? If that was alternating. I say that wrong. Did I say? I think I said something wrong. No, I'm not. Never mind. So, but if the signs are alternating, if you're multiplying by a negative 1/2, right, there also would be a sum for this as well. Okay? If R is less than 1, so that means a fraction or a decimal less than 1. Okay, but it can't, but we're not talking about less than 1 like -1 or -2 or -3. We're talking about absolute value of 1. So what that really means is R is between -1 and 1. That's what we're talking about. Okay, so if that R is a fraction like 1/2, 2/3, 3/4, -1/2, -2/3, -3/4, okay, then this applies. If it's not, then there is no sum. If you're multiplying by 2, if the numbers just get bigger and bigger, 1, 2, 4, 8, you try to add that up, it just gets bigger and bigger. There's no answer. Or -1, -2, -4, those are just getting bigger and bigger. Okay, so if R is outside of 1 or less than -1, either direction, then there is no sum. But if it's less than 1, then this formula works. And let me just, I'm sure Mrs. Payne talked about it, but not everybody was here, and there's no video. So let's talk about how that formula comes from this. Does anybody remember from yesterday? Can anybody that was here yesterday tell me? How does this formula here turn into this formula? No, n would actually equal, not the n equals 0. The r to the n equals 0. Let's talk about that. What is the n doing if you're talking about an infinite series? That's a number of terms. N is a number of terms. Well, if you're talking about an infinite series, how many you got? Infinite. So n is getting really big. But if r is less than 1, okay, so if r is 1/2, and you raise that to a really, really big number, right? What's 1/2 raised to 1,000,000? Something really, really small, because you got 1/2 times 1/2 times 1/2, so that's like 1/4, 1/8, 1/16, 1/32. It's like 0.00000, right? It's getting really, really small. 0.5, I mean, you do it in a calculator, you do 0.5 to the 100th, and it would give you like 0.000, probably scientific notation. So what happens here is if R is less than 1 and n is getting really big, which it would be with an infinite series, then this is basically becoming nothing. And so this becomes 1 minus 0, which is just 1, and 1 times A1 is just A1. And so that's what happens. And so that's why this formula is what it is. Okay? But it doesn't work if R is bigger than 1. Because if R is bigger than 1 and you raise it to a big power, that gets really, really big. And then this is just going to get bigger and bigger and bigger and bigger. Okay? All right. So, simple little formula. All you need to know is the first term and the ratio. That's all you need. And that will tell you the sum. Okay? So, let's test it with this one. We said we thought this should add to 1, right? Okay, what's the first term on this one? 1/2. What was the common ratio? What was R? Also 1/2. 1 minus 1/2. What do we get? We get 1/2 over 1/2, which is 1. Just like that. That's how easy that formula works. Okay? Earlier, yesterday, I think 2 days ago, I had this series up there. And we said that added to 2, right? Well, that's because your first term would be 1, right? So you'd have 1 divided by a half, which would be 2, right? So that formula gives that to you. All right, go ahead and try these. Try these problems here real quick. These have to do with geometric. And a geometric mean is just a term in a geometric sequence. So 2 geometric means, so what that means here is you have 6.4, then a term, and then 12.5. Okay? I think you had a problem yesterday that said arithmetic means, and those are just terms in between. So 2 geometric means 2 terms between those 2. All right, try those. If the question was, is it a geometric sequence, you would want to double check by dividing back all of them that were there. So -2/9 divided by -2/3. Oh yeah, that's 1/3. -2/3 divided by -2. It's 1/3. Okay? All right, what about this one? What'd you get for the ratio here? -2. So -10x minus 14 over 5x plus 7. You could take out a -2, which gives you 5x plus 7. Cancel, it's -2. Or, like I said, probably in your head, you can see you're multiplying by -2. Okay, so r is -2, and then just keep doing that. Write those out. I won't go into that. Okay? All right, what about number 2 here? Find the 10th term. Are you using the formula? I would use the formula. Now, you could keep just multiplying them out. What is r? Now, here's where it's a little tougher to use the calculator. Now, you can do 3 divided by square root of 3. You get a decimal, and maybe you know what that is, but I think it would be more like this. 3 divided by square root of 3. Now, what do we do with something like that? What Mrs. Andreessen teaches. Multiply top and bottom by radical 3. So you get 3 radical 3 over 3. Now, again, I'm not sure you need to do that, because it looks like if you take radical 3 times radical 3, that's 3. You take 3 times radical 3, or maybe it'd been smarter to divide these 2 backwards. 3 radical 3 divided by 3. Oh, there it is, radical 3, right? So we're multiplying each term by radical 3, so that's r. So what's our formula tell us? Our formula, let me get rid of some of this. Our formula tells us that the nth term, which they want the 10th term, is what? First term times r to the b to the 9. Now, how does that help you? Where do you go from there? We want to simplify it. How do you do square root of 3 to the 9? Square root of 3 times square root of 3 is 3, right? Well, you could do 3 to the 9 halves. I don't know if we could do this. I mean, okay, there's several ways here. Let's think of it this way. First of all, this is square root of 3 to the first. This doesn't always happen. But what's square root of 3 to the first times square root of 3 to the 9th? That'd be square root of 3 to the 10th. Right? Square root of 3 is also 3 to the 1/2. What's 3 to the 1/2 to the 10th? Power and a power, you multiply. Right? So now that's 3 to the 5th. 3 to the 5th is what? 243? 243. Now, you got your calculator too, though, right? And you got your calculator here, and you can just multiply that out. Since it comes out nice, 243, you're good, right? If it had come out in decimal, then you'd have had to kind of figure out what the square root, right? So just to think that through. The other thing you can think is square root of 3 to the 9th. Well, every time you pair a square root of 3 with a square root of 3, you get 3. Well, there'd be how many pairs? There'd be 4 pairs there if you're just looking at square root of 3 to the 9th, right? There'd be 4 of those pairs. So that'd be a 3 to the 4th, that'd be 81, and then there's this extra square root of 3. So you have 81 square root of 3, and then there's this other square root of 3 at the beginning. Well, that's 3, and then we get 243. So you could have done it that way. So we want to be able to handle those square roots. Okay, if it doesn't come out real nice on your calculator. So try it on your calculator, see what happens. Okay, let's get here to number 3. Let's get here to number 3 that we were talking about a minute ago. Okay, so what did you end up with right here? But how'd you do that? So we said 6.4, and you had to multiply that by R 3 times. And then that would equal 12.5. So then you would divide by 6.4. See what you get? What is that? Some decimal, right? Then what? Cube root it. Now how do you do that in your calculator? To the... No, it's not to the third.
I think we did it a different way. Would it be like the 1/3?
Do you have a cube root button? Is that what you're telling me?
You can do a square root of any number you want.
Oh, not the square root.
It's the root of any.
The whatever root. Oh, the second caret.
Yeah,
you're right. You're right. Here's in calculus, and it's just because powers work way better than powers work way better than roots. Is you would just take that number to the. Isn't cube root the same as 1/3 power? So if I'm going to cube root something or fifth root something, I would just raise it to the 1/5 or the 1/3. But you're right. Your calculator will cube root that. And that with decimals in that problem, it's okay to have decimals in your answer then. Okay? All right. So that's how you would set that up. Now, I heard Charlie saying to subtract, and you don't want to subtract when it's geometric, right? But you were talking about subtracting to see this gap. Well, the thought was good, except what should you have said instead of subtract? Should have said divide, right? So you should have said divide and said, okay, we're going to divide, and then that number needed how many things? 3 times. But it was multiplied, right? So you got it, so it's an exponent, so you got to do the cube root. Now, if this would have been an arithmetic, he'd have been correct. You'd have subtracted and then divided by, think about this, if this had been arithmetic, divided by 3, because you'd have had to add 1 to get here, add 1 to get here, and add 1 to get here. You'd have had to add on 3 times to get there. So you'd have subtracted these, saw the difference, divided by 3, and then added that on to each one to get those, right? But with geometric, you divide those, and then say, okay, I would have had it times by R 3 times, so I got a cube root. Okay, so very close connection between those. All right, number 4 then, I heard you saying, what's your R here? R is -4 that you get going backwards. And to find the sum, what do we need? We need the first term. We need 1 minus R to the n, which is 6, divided by 1 minus R, right? Just like that. Just follow the formula. What'd you get on that answer? -1630? Can't believe it. All right. What is the first term of this sequence? This is where you would do this formula right here. You would take your nth term, which is your 8th term, -384, and then your first term, which you don't know, times R to the, we have how many terms? 8 terms, so this would be 7. Okay, that's A1. Okay, so you would just take -384 and you would divide by -2 to the 7th. You would divide by -2 to the 7th, and that would give you 3. Okay? All right. So, questions on the homework?
$51
51 through 55. Okay? Now, have we answered some of those questions potentially?
Yeah.
As we've been talking about. So 55 says the third term is 16 thirds. Sometimes I'll write these out this way. So which one's this one? Oh, that's the wrong one. 55 says A2 is 2 and A3 is -√2. And they want to know the 5th term. right? So how could we do that? Well, this one's actually a little easier. Because what do we need? We need R and we need A1, right? So since we have consecutive terms, all we have to do is divide backwards, right? So negative root 2 divided by 2, that's our R, right? Doesn't simplify any easier than that. That's our R. So to find this fifth term, what do we got to do? We got to multiply by that twice. So we just take negative root 2 times this. Okay, negative root 2 times that would be, 2 over 2, that'd be 1. And then we would take that times negative root 2 over 2. And there'd be your fifth term. Okay, so let's do one that'd be a little tricky. Okay, let's do 53 maybe. 53, they wanted the fourth term, or they told you the fourth term is negative 18. And the seventh term is, what is that, 2/3? And they want to know that term. Well, now this is like the one we just did in the warm-up, right? So this is times R, times R, times R gives you that, right? So this would be negative 18 times R cubed equals 2/3, right? Negative 18 times R cubed would give you 2/3. So now we would divide, so R cubed, let's see what we get there. What's 2/3 divided by negative 18? So we got that? Negative 1/27. So now let's cube root that. What is that? Negative 1/3. So now we know we're going to times by negative 1/3, times by negative 1/3, times by negative 1/3. So 18 times negative 1/3 is 6. 6 times negative 1/3 is negative 2. Negative 2 times negative 1/3 would be that. So our sixth term is negative 2. Make sense? Okay? All right. I think it's more important with the geometric sequences to set it up so you can get that R cubed. I think with adding, with arithmetic sequences, you're adding, and repeatedly adding means multiply. That just is, I think that's just easier to deal with, right, than the cubing and the exponential. So I think setting them up like this and writing it out like that, I think is helpful. Okay, what else? Anything else on there? There wasn't much else that I assigned, right? And it was going over a lot of stuff, and there could have been more, but this works out fine. Okay, so let's look at a couple here together. Okay, so let's just talk through a few of these. Okay, so these are some sums. Okay, so I give you this problem here. So what do you want to do first? Because we're trying to do this, right? A1, 1 minus R to the n, that's an n, over 1 minus R, right? So we need to find those things for that. Okay, so we would start this process by expand it out. Okay, go. Expand it out and finish it here. Expand that out. And you don't have to expand out the whole thing, right? You only expand it out so you find the things you need. You need R, you need N, and you need A1. Once you got those, you can just go to the formula. How many terms are there?
10.
I got that right? First term is 1, isn't it? That's the key, right? Really, that's about all you need. And understand that R is when you've got 3 halves raised to the n minus 1. Remember, an exponential that's what a geometric sequence nth term formula is going to look like. Okay? So you're multiplying by 3 halves every time. So R is 3 halves. Okay, that number that's inside there raised to the power, that is R. Okay, what's that come out to be? I would like to have it as a fraction.
Yeah.
Does it come out as a fraction? Yeah. Everybody knows on your calculator how to do that, right? If it doesn't. Yeah, sometimes it may just give you a decimal when you have no choice, if you have enough terms. What are the numbers?
113, 169.
Over what?
No, 113.
Oh, 113. 113 and 169. 512, yeah. And at some point that will fit on your calculator, and then you'll just have to give a decimal. Okay, but if it's a fraction problem, now if this would have been 1.5 inside here, right, then go ahead and give a decimal. All right, do that one. Again, notice that it's a sum, right, so that's what it's asking. I mean, I didn't give any directions there, but the directions would be find the sum. Find the sum. What's R? 2, right? What's the hardest part of this problem? How many terms are there? How many terms are there? How do you do that? Magic. Just keep going.
Yeah.
Just keep going with your calculator. You could. 36 times 2, times 2, times 2, times 2, times 2, and then count. Write them down. Okay, how could you do it without doing that? How could you do it without doing that? I mean, if there were so many, that it would just take ridiculously long. But plus, we should just understand it. What formula would I use? I'll give you a hint. It's on this page. The first one, the nth term formula. Remember, the nth term is how you find a term. Okay, so what you would say is the nth term, because we don't know n, equals what? 9. Why? Okay, hang on a second. 9 times 2 to the n minus 1. And what would we put right over here? 1,152. The term that we don't know what term it is, because if we knew what term that is, then we would know n. We would know the number of the terms, right? So 1,152. Now, if you don't know how to do this, then I'm just going to fail you, and you can take this class all over again, because because obviously you haven't learned anything. Okay, that's harsh. But this is what we did the last chapter. We solved these, right? How do we solve an exponential equation where there's a variable up here? What would you do first? You would divide by 9. So do that. 1,152 divided by 9 is 128 equals 2 to the n minus 1. How do we solve something like that? Do log base 2 of both sides, or do a change of base kind of thing, or do, change it into, we could just change it into log base 2 of 128 equals n minus 1, just like that. So you would just use the nth term formula right here to find the number of the term, to find n. So, how do we type this into our calculator? Log 120 or ln 128 divided by ln 2, or use the log button, either button, doesn't matter. Ln 128 divided by ln 2, and then add 1. And what do you get? 8. Okay? And so now that we know that n is 8, we can go put an 8 right up here. Okay? So that's important. I want you to be able to do that. Know how to find an nth term. If you've got a certain term out there, you don't know which one it is. That goes in for the a sub n. First term goes here. You know your common ratio r. You can figure out what the term is by setting up this exponential. Remember, you have to get the exponential by itself, so you got to divide by 9. You can't take 9 times 2 and make 18 here. That doesn't work. You got to divide by 9, and then do a log, and then solve it like we did last chapter. Okay? All right, we'll do 1 or 2 more, and then I'll let you work. Like I said, it is going to work best for us to do a quiz on Monday. You okay with that? Okay. Well, we're missing people, and we didn't get quiz. Monday will be fine. And we'll review some Monday. We'll review some Monday before we take it. So we'll have a lot of work time tomorrow. We'll have a lot of work time tomorrow. Lots of review stuff. Okay? But, so we got stuff to do. So we come back from lunch. We'll finish up this. I got some problems in the book for you to do. Then I got a worksheet, and then, well, maybe a worksheet. We may do that worksheet tomorrow. All right? All right. Next problem. formula we using? Infinite sum, right? Which is A1 over 1 minus R, if it's a geometric sequence. Now, on the quiz, I will, a lot of times, may use the term arithmetic sequence or geometric sequence, right? And which kind of tells you which one you're dealing with, but then may not either, right? Just give you this and say, evaluate that, right? Evaluate means find the value, and understanding that you know sigma means sum, so this is adding up, and then and recognizing that it is a geometric sequence because you're multiplying by what? What's the R? The R is going to be the 2/3 because as n increases, you're multiplying by 2/3 and multiplying again by 2/3 and multiplying again by 2/3. So in that formula, you need A1, the first term. What's the first term? 2, and the R is 2/3, and so final answer? 6. Okay. Now, I went ahead and expanded it out, but really you only needed the first term. You can recognize that it's 2/3 is the R, but 2 times 2/3 of the 0 is 2 times 1, and then so forth. So on. Now, get your calculators out. Just curious here. Let's add up. Let's do it, and let's change it to decimal. So let's do 2 plus 4/3. What do you get? Plus 8/9. Did I do that right? Is 8/9 the next one? Why didn't that seem right? Yeah, that's right. And then the next one, and we might have to go too far, so this might not work very well. 8/27 times 2, what would be the next one? 16/27. What are you at so far as a decimal? How much? Okay, let's keep going. So the next one's going to be 32 over 81. Are we at 5 yet?
Yeah.
We're over 5. And the next one will be 64 over 243. What are we at? 5.47. So you can see what's happening. It's going up, but like smaller and smaller amounts. Let's do one more. So that'd be 128 over, help me out here, 6, 7, 29. Now we're at 5.6 something, and so what's happening is it's going up, but it's going up by smaller and smaller amounts, and so it's going to start getting closer and closer to what? 6. It's getting closer and closer, so as we keep adding, but what's happening is this bottom number is getting a lot bigger than the top number, so the fraction's getting smaller, and it's so that when we get way out here, pretty soon, that fraction we're adding on is going to be kind of a 0.00 something, and pretty soon we're going to get 5.834, and we're going to get 5.9926, and pretty soon at 5.999999, right? I mean, and so we'll never actually get to 6. If we would keep doing this, it would never get to 6 until infinity. But you can't get to infinity. So, really, it's about a limit, and the idea of a limit, something we'll talk about in our last few days, but as a calculus idea, but that's really what you're saying. The sum is 6, but in a sense, you can't really add up an infinite number of things, but what you'd say is that's the limit, like the doorway, when we go half, then half, then half, right? The limit is 6. It's tending towards 6. That's where it's headed, right? Okay. All right, it'll keep getting closer and closer and closer to 6 where it can't go above. All right, one more, and then I'll give you some problems to work on. Okay? So, again, the question here would be find the sum. And since it ends with ... what do we do? Infinite. Okay? So much like you just did. Just a different way of writing the problem. Okay? But it's the same question. done already?
Yeah.
Oh wait, what do you need? It's an infinite series, right? Infinite sum. So all you need is A1 and R. However, the thing that you maybe assumed, which is pretty easy right now, but on the quiz where we're dealing with all these things, your assumption was it was geometric, right? Now, it's also pretty easy to assume that since you can't do the sum of an arithmetic series. Let's talk about that a minute, right? An infinite sum, right? Notice we did not have a formula for the infinite sum of an arithmetic. Why not? Because when you just keep adding, even if you're adding negative, it'll either keep getting to be a bigger and bigger positive value or a bigger and bigger negative value, right? It will never converge to something. It's only a special property of ones like this, geometrics included, when the R is less than 1. But with arithmetic, there's no way. There's no way it would add to something if you went infinitely. So if you're adding an infinite sum, for our purposes, it would have to be geometric, right? And what is the R then? 2/3. Now, I did more work than you probably need to do, but if you had a series of problems, which you did have in the essay's homework, nobody asked about it, is it geometric? And that's what that would look like. That's the divide backwards I was talking about, okay? So you would do 6 divided by 9. Oh, that's 2/3. You do 4 divided by 6. Yes, that's 2/3. You do 8/3 divided by 4. 8/3 divided by 4 would be 8/3 times a fourth. 8/12. It is 2/3. So the proof is there that it is geometric. The R is 2/3 and 27. Is that what you got? Okay, so that's what those would add to. Again, same thing. 9 plus 6 is 15, plus 4 is 19, plus 8/3 is like 21 and a third, and on, or 2/3, and on and on and on. It would be getting closer. Eventually, it would be getting closer and closer to 27. Would be kind of the limit of where it would reach. Okay, so let's go ahead and we'll make this be the homework, and we'll just stop with that. No worksheet. We'll work on those things tomorrow. Okay. So if you're gone yesterday, you can get caught up on the other stuff as well.
your sins, just me and you.